Hey everybody, Mrs. Kroll here. In this video, I'm going to be going through the multiple choice questions on the Chapter 1 review. As always, pause the video to try the question first and then use this to help answer any questions you may still be lost or confused by. All right, so the first one, it says, let f be the function given by f of x, this piecewise function here, and we're trying to figure out which statements are true, 1, 2, or 3. So we're going to start with the limit as x approaches 0 of f of x equals 2. So I'm looking here. If I want the limit to be true, then I know the limit as x approaches 0 from the left of f of x needs to equal the limit as x approaches 0 from the right of f of x. So if I would approach 0 from the left, I would be looking for x is less than 0. So that would be plugging it into this top equation here, which is going to end up being 3. And then if I would go 0 from the right, I need something that's greater than 0. So x is greater than 0 on this second equation. So that's going to be plugging in 0, 2 minus 0, so 2. The left and the right-handed limit are not the same, so this first statement is false. And then we're going to look at the limit as x approaches 2 equal to 0. So then I'm going to look at the limits again from the left and from the right. So the limit as x approaches 2 from the left would be something that's less than 2, which would end up being my middle equation. Plugging in 2 there is going to be 0. And then plugging in the limit as x approaches 2 from the right of the function would be something that x is greater than 2. So plugging in 2 here, 2 minus 2 is the square root of 0, which is still 0. So left and right-handed limits are the same, so this one is true. Then we're looking at the last one here. Saying we want the limit as x approaches 1 equal to the limit as x approaches 6. Well, both 1 and 6 are not part of the breaking points of that piecewise function, so we can just use direct substitution, making sure that we plug it into the correct piece. 1 is in between 0 and 2, so I'm going to plug it into this middle one. So the limit as x approaches 1 of f of x would end up being 2 minus 1, so that's 1. And then 6 is greater than 2, so that's going to end up being the limit as x approaches 6, getting plugged into this bottom one. F of x, 6 minus 2 is 4. The square root of 4 is 2. So those are not equal, so this one is also going to be false. So the only one that we have for a true option is going to be 2B. All right, then the next one says the function of f is shown above in that picture. If the limit as x approaches a of f of x exists, so the left and the right-handed limits are the same, but not continuous at a. So this is pretty much what we're looking for, a whole, so that the left and the right-handed limits exist, but not continuous, so there's got to be something else going on with the graph. So a could be -1. Well, looking at -1 here, that limit does not exist, so that's gone. At 0, the next one, again, the limit does not exist because of that jump, that break that we have. And then the next one it's asking for is 2. And when we look at 2, all right, my limit here from the left and from the right exists. But the dot is farther down, so it's not continuous. So this one's going to be C. All right, number 3 is looking at the properties of limits. Given that the limit of x equals 0 of f of x equals 9, the limit as x approaches 0 of g of x equals -9, and then the limit as x approaches 0 of h of x is 5. Find the limit as x approaches 0 of g of x divided by h of x minus f of x. So what we're looking at here is to use the properties of limits so we can take each limit individually and then subtract them and divide them. So the limit as x approaches 0 of g of x is -9, so that's going to be the numerator of my fraction. And then I can subtract the limit as x approaches 0 of h of x minus the limit as x approaches 0 of f of x to be the denominator. So that's going to be h of x first, that's 5, minus f of x, which is 9. So this is going to end up being simplified down to negative 9 over negative 4. Negative divided by a negative is positive, so C. Next one, the limit, again, we're trying to figure out which one is true. Okay, so the graph of the function g is shown below. And we're looking at the limit as x approaches 2 of g of x. So that's your left and your right-handed limits coming from both directions. And that is coming to a height of 1. So this first one is true. Then the next one, the limit as we approach 2 of g of x is equal to the value at 2. Okay, so we knew the limit is 1. That's what we said on that height there for the first question. But my filled in dot is not at that same height. And so the function value is not the same as the limit. So that is false. And then finally the last one, just kind of erasing here. All right. Looking at 3 and that g is continuous at 3. So your limit exists, which is true. You have a function value at 3, which is also true. And then the limit and the function value are the same. So that is also true, making it continuous at 3. So 1 and 3 are true, which is going to be the answer of C. All right, number 5, it says the graph of f is shown above. Oops, it's actually below. All right, the line of x equals 1 is a vertical asymptote. Which of the following statements about f is true? So the limit as we approach 1 is positive infinity. Well, at 1, since there's a vertical asymptote there, since it's not a one-sided limit, this should be does not exist. So that is a false statement. Then the next one, the limit as we approach 3. Ooh, and 3 again has a jump. It's discontinuous, and we know jumps do not exist. So the limit as we approach 3 does not exist. All right, then the next one, it says, well, what's the limit as we approach from the left and from the right? Okay, so then as we look at the limit of 3 from the left, that's going to have an answer of 3. And as we approach from 3 from the right, that's going to have an answer of 2. And that inequality doesn't work, so C is also false. The next one, the limit at 4 does not exist. 4 is a nice continuous part of the curve there, so that definitely does exist. Probably around 3. That's what it looks like from the graph. So then process of elimination, we know it should be E, but let's double check and take a look at this. It's saying the limit as x approaches 0 from the right. So going from the right hand, getting up closer and closer to 0 is going to be an answer of 2. And then from 3 from the right, we looked at that one before in C, that is also going to be 2, making E my true statement. All right, number 6, we have another piecewise function. Which of the following statements is true? So it says that f of x is not continuous at 4. All right, so we have this function here, and we really need to figure out what's going on at 4. So let's just take 4 and plug it into this rational function, because then we can start to figure out what is happening at 4 to help us decide if it's continuous or not. So plugging in 4 here, I'm just going to write it out this way. So 4 squared plus 4 times 4 minus 32. And then in the denominator there would be 4 squared minus 2 times 4 minus 8. So in this top part, we have 16 plus 16 minus 32, so that's going to be 0. And in the bottom, we're going to have 4 squared, so that's 16 minus 8, so that is also 0. When we do direct substitution and we get this nice part of 0 over 0, that tells me that there's a whole at 4. Which is great because then we know it's not continuous. Except in the piecewise function, it says that at 4, we're going to have a filled in dot at 8. So really we need to decide, is this point here of 4h, that dot, does it fill into the whole of this first function? So I need to find the limit as I approach 4 of this function. And so we know when we have the whole, we can factor and reduce of this top function. So the bottom is going to factor to x minus 4, x plus 2. And in the top, it's going to factor to x minus 4, x plus 8. So the x minus 4's cancel. Direct substitution here, 4 getting plugged in here, 12 over 4 getting plugged into the bottom is going to end up being 6 to give me an answer of 2. So I have a height of this rational function. When it hits 4, it's going to have a height of 2, and this filled in dot is going to be at 8. So this is not continuous because the graph is going to be much lower, and then that filled in dot will be much higher. All right, the next one is looking at, as we go out to infinity, the graph is going to have a height of 4. That would be basically saying that it has a horizontal asymptote at 4, which this graph does not. So that is also false. Oh, I realize this just tricked me with this double negative. This graph is not continuous at 4, so this is going to actually be true here. Got it, double negative, not continuous at 4, so that part is true. All right, finally, the last one then, x is equal to 4 is a vertical asymptote in that graph. Going back, we know that 4 is that whole because when we took 4 and plugged it in, it was 0 over 0. So this is false. It's a whole at 4, not a vertical asymptote. So the only one that is true here is 1 to give me an answer of B.